I think that's enough to get on with, so we're familiar with those symbols, and we'll have a look at these when we look at the experiment. I've got here an electronic set. Now the electronics consists of just a lot of metal pillars and various things that we can put through. So I've got here just an ordinary straight piece. This represents a wire, and so I can push these either one way or the other to build up our circuit.
So let's start by building a very simple circuit. I'm going to start off with
my battery, and this is a boring battery because what it consists of is a mains power supply, a DC power supply. I'm going to use that rather than using batteries, and let's get a very simple circuit working. Electricity then is going to come out of the positive, go round this wire, let's go into a bulb, and then we really ought to put in a switch in each circuit. It's probably the best and easiest way of trying to do it. And here, by pressing the button, the circuit lights. If I put this round the other way, the circuit works exactly the same. Doesn't really matter sometimes which way we put the items around. I can make the circuit bigger, and it still works in exactly the same way. The only difference that we've got is that the path is slightly longer. Let me see if we can move the camera a little bit to make life easier for you to see. Hopefully you can see a little bit better then what's going on. Right, now there's my simple circuit. What happens if we put two of these bulbs together? We'll replace a wire with one of these bulbs, and now we see instead of the bulb lighting brightly, it's much dimmer. It doesn't matter if I put that bulb there or there, it's the same circuit, and we would draw the circuit in the same way. I can take those bits of wire out. I can put my bulbs like that, and again they light in exactly the same way. If we're going to do this, we need to try and draw this out. got here the electron flow, the flow, if you like, of charge. So we can have something about this charge flow, and I'm going to give that a measurement, and we're going to call this the letter Q, and we're going to measure it in something called coulombs. Coulombs, invented by, never guessed, someone called Coulomb. And the charge flow equals the amount of current, and the current we're going to measure here, I'm going to call it letter I, we're going to measure that in amperes, or amps for short, times the time taken, and the time we're going to measure in seconds. So we can measure how much charge flows if we know the current and we know the time. And this is a simple series circuit. So if I were to take a little meter, and I've got a couple of different meters that I can use, they look to all intents and purposes identical, apart from the fact that one says A on it for amps and the other one V for volts. At the back of them they do look very slightly different. So to use an ammeter, then what I need to do is replace something on the circuit with this. It's not quite big enough, so let's build the circuit up again. I've got my switch coming out, I'm going to my bulb, I've got my sun moving the tripod. I was a bit busy thinking about what I was trying to do there. I ran out of space. I'm going to do this one again. Just giving myself a few more bits of circuit so I can play with it a bit easier. So I've made a slightly bigger circuit. And if we put the switch on, they glow the same. If I take one out and I replace that bulb, then you can see it glows brightly. If I had it in the other position, it would also glow brightly. Someone says, but you used a different light bulb. Okay, so let's put the two light bulbs in. Both are dim. If I take this one out, now that one's bright. And it doesn't matter where I put it in the circuit, as long as the electricity is flowing around here, it's going to glow brightly. Let's take one of these and we're going to put an ammeter into the circuit. And I've got choices of which way round I put it. Let's try it this way. And if I put it round this way, I've got positive on the positive side, so it does work, and we need to see this ammeter working. Well, you can't see it very well there, so I'm going to turn it round the corner. And hopefully now you might be able to see this working. So turn it on, the bulb lights, and you'll see the ammeter is moving, and we're moving up to 0.1 of an ampere. And if I run this for a few seconds, we can measure the amount of electricity going through. The ammeter's not changing, and I'm getting some electricity flowing through. So putting it at this position here, we had 0.1 of an amp. Let's take this one here. It only flashed because I hit the switch. let's put the electricity in here, and how many amperes, let's turn it round so you can see. .1 of an ampere. Let's put this, I've done it there. Doesn't make any difference if I put it here or here. Let's put it after the bulb. Let's see what happens. And I'm going to switch on again. And you'll see that we're getting 0.1 of an ampere and the bulb lighting. Doesn't matter where I put the ammeter in this circuit. So wherever I put it in this circuit, we're getting the same amount. Let's go and work out the charge for this. The amount of charge we've worked out is the current times the time. The current was 0.1 amperes, and if I ran this for 10 seconds, then I would produce 0.1 times 10, which is going to give me 1 coulomb. That's just the amount of charge that's passed through the circuit. Now let's see what will happen if we change the circuit a little bit to see what happens. Okay, so let's have a look at a few more components in the circuit. We've got a whole series of different things that I can put in, and I'm just going to grab a resistor. Now this resistor, if the system will focus on it, there we are, this is a 12 ohm resistor. If I look at the other side, you'll see it's just got this little tiny little bead resistor. It's actually got different colours on it, which you might be able to see if we can focus on it. Just about, and the different colours represent what the resistance is. Let's look at the whole circuit, and let's remind ourselves what it looks like. I'm going to replace this wire with a 12 ohm resistor. Let's see what happens. Certainly a little bit dimmer. Bright, dimmer. That's a 12 ohm resistor. What would happen if I put a stronger resistor in here? Let's have a look at putting in a 100 ohm resistor. So this is my circuit. Put a stronger resistor in here, and the bulb not lighting up as much. But there is one bit of interest in this. Let's look at the ammeter carefully. So I'm going to tip this up so you can see it, and we're going to switch on, and with the 100 ohm resistor and the bulb doesn't light as brightly. And what's the reading on the ammeter? Nearly 0.1. Let's compare that with putting in no resistor. Trying to hold this up and do it is difficult. A very slight difference in the ammeter. Perhaps I need a better ammeter to see the real difference here. But what we can see is that by replacing the wire with a resistor, we are getting a difference in the brightness of the bulb. There's another type of resistor, looks a more complicated type, and let's take this one out and let's try and see what happens. I'm going to change the switch. This is just a push switch. I'm going to do one that stays on all the time for convenience, so I can switch this switch off, and when I'm ready to use it I can switch it on. And what we can do is we can change here this resistor. Now let's do that, and we'll watch the ammeter very closely. As I turn this down, the light's becoming dimmer, and we can see the ammeter is changing. So there you can see it working just by turning down the bulb very slightly till it's there, just barely glowing. We're getting a difference on the ammeter. So a variable resistor here, we're changing the amount of resistance that goes through from none to lots, and that is stopping the bulb light. What's happening to the electricity? Well, the electricity is going round. It goes through this thing called a resistor, and the resistor, from its name, sounds like it's resisting the electron flow. Let's go and have a look at that. Resistor, we've got a large piece of wire, and then we go down into a resistor which is a small thin piece of wire, then going back out to a wide piece of wire. So this is my wire, this is my resistor, and this is my wire again. And in here I've got the nice little flow of electrons, and they're going along quite nicely. And then suddenly they've got to all squeeze into this tiny little resistor before they can escape and come out as they go along. So they're really going to be bunched up here, and they're going to hit the sides lots. So this is usually going to generate a fair amount of heat, and if we're losing energy as heat, then all the energy going through here won't be the same as the amount of energy going through there, because we've lost some. It's actually being used up, and if this energy here is being used up, then what we've got is less energy available, less coulombs available, because we are using up some of these electrons. This current is being sort of lost somehow. There's a resistor. So think of it as a little pipe, and the little pipe sort of makes it more difficult for the electrons to get through, and they're going to bang against it and they're going to get hot. And it's the principle that an electric fire works on. So we could have a diagram, I suppose, for that, and we could have a little box, it's a resistor, and we shall have some lines on it, and this is a heater. Not necessarily the same as a resistor, but this one actually getting hot. And sometimes when we want one of these, we want to do something a little bit more carefully, and we have a resistor with a line through it, and this is a fuse. This is a small piece of wire that carries all the electricity in your house, and if you put too much electricity through it, something goes wrong, then this little wire melts, and what we get is a fuse that will have blown and broken, and that won't work. And the idea is it saved the circuit from being damaged because this bit got broken instead. Okay, so we've looked at this idea of a circuit, we've looked at the idea of electrons flowing around. Let's see what happens if we put some other devices in there. Let's go back to my basic circuit, and I'm just going to put in my bits of wire, and I'm going to take out a new little toy to play with, and this is a diode. Let's put it in the circuit and we'll see what happens, and the answer is, well, not a lot. I'm going to replace the diode with a bit of wire, look at the brightness of the bulb, and you'll see that there really isn't a lot of difference here. So what's the diode doing? Well, I could have put the diode round the other way. Let's try it round the other way. Switch is still on, but the light isn't working. Turn the diode round, and now electricity does flow. So if we look at the shape of the image of the diode, I'll turn it round the right way to the camera, we can see it's a little arrow, and if electricity is flowing in this way, it can carry on, and if electricity is flowing in the other way, then this little bar is stopping it. And if you're interested why my fingers are all red, then you should have watched my program that I did on biology earlier today. So a diode, quite useful for allowing electricity to flow just one way round a circuit. And I might have some circuits that are going to need electricity just to flow one way round, and we can use those. When I drew out the diode, I drew a different one. I drew an LED. Here is my LED. Let's replace this diode with this LED. And there you can see my LED has lit. To protect the LED, I need to put an extra resistor in there, and that stops the bulb lighting because all the electricity is being devoured by this resistor. If I turn this round, then the LED is going the wrong way. Electricity is flowing this way, not the electrons, electricity is flowing this way, and it can't get through, and so the LED does not light, but it will light the other way. But we're using up so much electricity there to protect the LED that this bulb won't light. It'll only light if I can put through a piece of wire. So there's our diode. So we've looked at some resistors, and we've looked at some other bits and pieces. Diodes, resistors, bulbs. What else is there to look at? Well, we can look at a few little resistors and investigate some of their properties. And what I've got here are 4 little resistors which we'll have a look at and see what they do. Now, I did say that these resistors are different, and I'm just going to hold these up so that Paul's going to try and zoom in and have a look at them, and you can see that they're slightly different colours. Paul made my life much more difficult then. You will miss that bit. Right, so they've got slightly different colours, and that symbolises what the different resistor is. I have no idea what these are. They've all muddled up. So let's have a look at them and see what we've got. I've got something to mount my resistors on. I've got this little carrier, and what I'm going to do is I'm going to take one of these, and let's see if I can get my resistor on there nicely. I'm going to cheat and do it so I can see what I'm doing, and if Paul can focus on it and you can see what I'm doing, good, and if not, it's more important that I get the resistor on. Well, there we are. It's not on very well, and I think what I need to do is to just tighten that up a little bit. So I'll get my special screwdriver out. Right, so we've got a little resistor here. Let's have a look and see what it does. And the bulb is certainly a little bit dimmer like this. We could measure perhaps how much by putting over my ammeter. So a little bit of difference with this one, so not a lot. Let's just undo this one, and we'll try a different resistor and see what that does. Right, so there's my first resistor, and that didn't make much difference. Let's compare it with a different one. So I'm going to make sure my wire's bent round sufficiently. I'm going to put the hooks on. And we'll do it up to make sure we've got good contact. Right, here we go. Let's try this one. Well, that seems brighter than the previous one. Okay, so it obviously is not making as much resistance as the previous one. So let's take that one off, and I'm going to put that one there because that one's less resistance than that one. Let's take my next one. Let's bend the wires round so they're not going to touch each other. I can then hook this one over. At least I will if I've got the screw done properly. And we'll do that one up, and then we'll do the other side. Do that one up. Let's have a look at the brightness. Well, barely any difference in the brightness, so that one seems to be even less. So, least resistance, middle, the most resistance, at least so far. And let's hang the last resistor on here. And nothing. I know the circuit still works, but with this resistor, no lights going through, not being lit at all. I can't even see a tiny little glimmer here. So this resistor, and it does work, is the strongest of them. So just by simple observation, we've put a way of looking at the strength of different resistors, which ones resist the flow of electrons the most. And I would expect, if I were to put a thermometer on these, that the one that resisted the most would actually get the hottest. It would dissipate the most heat, and the one that did the least would get rid of the least amount of heat. I usually end up with students given a little problem, and one of the problems I ask is about getting light bulbs to light. So let's look at a little problem. I've got two light bulbs, and when they light up with not much. Put one in, it's bright. So can you manage to design, lay out a circuit so that I've got two bulbs and they're the same brightness? And I typically find that students go round and they put it in different places, they try it there, see if it's going to be any better, and it's not, and they try it there, and then some of them think, well, it's going to be better if it's nearer the battery, and it's not. And it doesn't matter where I put it on this circuit, it's the same. I've got to change the idea. What I want to do is I want to now allow my electricity to go around my circuit in two ways. Either it's going to go around here, or it can go around here. And you'll see now both bulbs are lighting with about the same brightness. If I take a third bulb and put it in the circuit, oh yeah, someone said, you've got the light round the wrong way, you cheated. Okay, sorry. There we are. It doesn't make any difference which way the electricity goes around the bulb. If I take this one out and put two bulbs in their place, I now get two dim ones and one bright. And in the same way, I could have put that one down there and do that. And if you're worried that the bulbs are cheating, I can swap them over. And it doesn't matter which way I put them round. This one, where there's only one, is going to be brighter because these two circuits are in parallel to one another. Better have a look at this circuit. So let's have a look at the two different circuits that we've managed to make, because these are important. when we're trying to design a circuit. And although many books don't cover this till later, I feel it's important because when students are trying to build a circuit, they tend to go wrong. So I've got here my little circuit with my bulb in it. So here's my switch, and here are my bulbs. So this is a parallel circuit. Might get it in the right place for you. In my parallel circuit, electricity can flow either this way, way 1, or it can flow this way, way 2. And what we notice here is that both bulbs are bright. If we look at it the other way round, other circuit, and you can probably remember that is a series circuit. That both bulbs are dim. So what's happening? How can we measure this? Well, we could put the ammeter in here and see what's happening. So let's finish off by doing that. We know that when we put the ammeter in, that we put the ammeter in by simply replacing something in the circuit. So let's have a look here. This one's still bright, this one's still dim, and we can see the ammeter here. This is reading bit under 0.1. Let's take this and put it the other side. Still dim, and my ammeter, now you're going to be cheating, we're going to make it read it upside down, is reading about the same. Okay, what would have happened if I didn't put it there, but I put it here? With only one, and put 2 in, and now you'll see the ammeter upside down is running about 0.2. I'll be kind. I'll turn it round for you. So 0.2 now. So going round here, it was about 0.1. Going through with both going along here, because it can go either route and then through here, 0.2. Let's see if we can put it about there. Now, if I'm not careful when I do this, it sort of makes lots of funny connections. So I'm going to do it this way and turn it round for you. I'm not going to connect it properly. and we can see it's about 0.1. I can't turn it round the other way. If I turn it round the other way, it goes negative, it goes the wrong way. So the best I can do for you with this particular circuit. So if I put it in here, it's about 0.1. If I put it in here, it's about 0.1. If I put it in here, coming out, it's about 0.2. They seem to be adding. Let's take the switch out and I'll put it in before the switch. And if we look at the reading on the ammeter now, it's about 0.2 again. So let's have a look and see what's happening here. To put in the ammeter at a point in this circuit, and we're going to draw the third circuit out, the one that we've actually got. So I've got my battery, I've got my switch, and then I've got my little bit of choice here. I can either go this way or we can go the other way. I think that's more or less our circuit. We've got here our switch, we've got our single bulb, and we've got our double bulb. So I'm going to label this one B for it being bright, and I'm going to label these two D for being dim. And what we did, we put an ammeter in different places. We put an ammeter in instead of the switch, we put one over here. And we replaced a piece of wire and put the ammeter in. And I'm going to call this position 1. Ammeter 1, we got 0.2 amps. When I put it here, we got 0.1 amps or amperes. When I put it here, or in fact there, it doesn't make any difference. We got 0.1 amperes. I've got it after this. We got 0.1 amperes. And when I put it coming the other side, 0.2 amperes or amps. So I've got 2 going here, and it looks like 0.1 of the amps went this way and 0.1 of the amps went that way. The amps actually split and then they joined back together again. So this is something we see in series circuits, that the amps, when they go through, are the same, and when they're in parallel, they split. So hopefully that's given you an introduction to some of the electricity. We've just looked at then the basic bits of electricity flowing around a circuit. But we've got to have a circuit. It flows from positive to negative. It's the electrons that flow from negative to positive. We've got then 2 types of circuit, series and parallel. Series circuit, all electricity flows through each item one after the other in series, or parallel, they can go one route or another. we've looked at a few devices, a resistor which will somehow eat up some of the electricity, and we've looked at a diode which is a miserable device really, allows electricity to flow one way but it won't let it go the other. Next time we'll have a look at this idea of resistance, and we'll look at potential difference, this idea of volts, the push, and we'll explore more circuits that we can have a look at, discover what they do, how they do it, so that you can become an expert on this. Any questions, Paul? Not this time. Right, so until next time, if you like this, please subscribe, and I will see you next time, and we'll look at more electricity. Take care.